Studio, and I have this nice continuity where the DAC pack went to the database professionals for deployment, and it went to me to continue development on top of the exact same schema. I have all of my tables here and so on. I also pre-created an entity data model on top of this database that has only a couple of tables. I have the publisher table and the title table, and I also adjusted a few columns, did a few renames, used the mapping feature to adjust the database projection of the schema to something that fits my application needs. Now, one thing the Entity Framework team did a great job in the Visual Studio 2010 release was listening to customer feedback and adjust the direction of the product so it fits the needs of everybody that was using the product. The example I want to use in that context is that of the domain-driven design community. These folks gave us strong feedback that for certain scenarios it was very important to separate the domain model, which is my .NET classes that model the domain I'm working my application for, from any storage concerns. And they wanted a strong division in the middle. This was very tricky to do before, and I wanted to show you how we can get that going in this release of Visual Studio. So in the default experience for the previous and the current version is that when you create a schema, if you pick underneath the EDM file, there is this designer file where we actually generate Visual Basic or C# code for each one of your entities. So you can drill in here, and you can see entities inherited from some base class. They have a bunch of attributes and so on. Depending on your design methodology, this could be great because we do a bunch of work for you, or this could really get in the way because it doesn't fit your requirements. Folks, one of the things they needed was completely clean .NET classes. So let's get one of those going. I'm going to close this, and what I will do is I'll ask Visual Studio to stop generating that code automatically. I'll do that by removing these custom tool attributes from here. So now if I go back to my project, you can see that there's no more code file in there. Instead, what I'll do is I'll add a new class file. Let's type class here. And this is the pubs database. So I'm going to call this pubs. And first thing I want to do here is create my domain types. Remember, we had a title type, which maps to books, actually, and a publisher type. So let me copy a couple of classes here so you don't have to watch me type. So this is my title class. It has a few strings for the ID, the title, the type. It also has a price. And here's the publisher. You can also see that there is relationships between these domain objects. A title has a publisher, and I just simply have a .NET reference. Similarly, a publisher has a list of titles here. And you can see that one is a regular reference, the other is a list of titles. These classes look exactly like you would type if you're just doing these objects in memory. So no storage concerns whatsoever. This is called persistence ignorance. So now that I'm done with this, the one thing I need to do, which I typically would do in a separate place to avoid mixing concerns, is creating a class that represents the entry point to my storage layer, to my database. What I just did here is I kept the class. I gave it a base class. Let's resolve this. I'm picking up the connection string configuration, connection string from configuration, of course, so we can deploy this and change settings. And I added these two sets, one for titles and one for publishers, that point to my types. So at this point, this should build. Let's make sure it does. It does. So at this point, I have a fully working entity framework setup where I have titles and publishers. I can do language integrated query against these. These types can be the results of store procedure calls. Everything just works as usual, except that instead of going first on the model and have it go generate code, I actually typed my code exactly the way I liked it.
That's great.
So the other topic you touched on was the data services, the AD.NET data services. The purpose of data services is to give you a RESTful data service interface on top of data sources you want to share with other applications. Now, data service is a model-driven system where the data that comes in is in terms of the entity data model. One thing we made sure is that we don't introduce any seams in the system. So whether you start database first, model first, or code first, we always derive a model from this, and then we can build these value-add layers on top, regardless of how you started. So let me show you how to quickly create an AD.NET data service. That's a long name for the thing. There. So we'll call this service also pubs data. So the template for data services expects us to give it the source for data. I just created this. This was my pubs class that, remember, contained the titles and the publisher's extents. And since this creates a service interface accessible through HTTP, the service is locked down by default, so people don't party on your data, basically. So now what I want to do is say I want to enable access to titles and to publishers, and I'll make titles read only, publishers read only, and titles read write. So I can set up more sophisticated policies and control sort of globally how I want to have access to my service. We can get rid of this. Finally, before I'm done with this service, usually services have like a varying degree of business logic between that and the database. You don't want to just short circuit the database. You want to add value to the data and control it so people do and see exactly what you intended. Let me give you a very small example of that. I'm going to bring in something called a query interceptor, which is simply a function that runs every time somebody queries a particular table, in this case, and the titles table, or we call it entity sets in the entity data model. And what this does is it returns a predicate. So we can very efficiently push this down to the database. In this case, books are maybe mid-flight while we're publishing this data. So those books that don't have a decided type, I don't want them to be visible publicly. So I'm filtering them out. Now, it doesn't matter how you reach a set of titles. You will never see this because the predicate applies as a policy across the board. So let me actually come here and view this in the browser. So now we have a working service. And when I do view in browser, this is not what you would share with your users. This is just to show the kind of simple entry point we have into the system. Browsers do just an HTTP GET to obtain data from a given URL. So in this case, it authenticated with integrated auth. And I have a simple URL format where here I have the entry point with all the tables. And I can do simple things like /titles. And I will get a standard atom feed, so nothing invented here, where each entry represents an entity or a record in my database. So the key point here is I just did an HTTP GET from a URL, and I was able to reach to this information. And I can also, if the developer and the administrators decide to, I can do puts and deletes and update the data in this system. And the highest order bit is the only thing I need to participate in this space is an HTTP stack. So anybody with an HTTP stack can consume and produce data in this environment. So the entry bar is as low as it gets, and interoperability gets really benefited from this. Finally, we talked about, well, we have data services. We have a framework for you to create solutions that produce and consume data this way. How about our own products? Let me briefly show you 2 examples of this. Of course, we have a developer story that fits well with this, and you can create clients for the server I just created. I wanted to give you an example of something that is not a developer tool, but a business intelligence tool. Here I have Excel 2010. And what I'll do is I'll use Power Pivot, which I installed the plugin. And so I created my application. You can imagine the application having a front end. But now I want to do BI over my data. So I didn't do anything special on my middle tier. Of course, I can import from a database, but sometimes it's not appropriate for an information worker to hit the database straight. I want my business rules in the middle, like the one I just introduced. So I can now also say import from a feed. And if I switch back to the browser, I can grab the URL I used before, give it to Power Pivot. Power Pivot will inspect the service, obtain information about the entity sets available, list them here, and I can say choose all of them, click finish. And now you can see my role here is the one of an information worker, so I don't need to write code. What I need is to go, I know the data set very well, and I want to find insight in that data. So now I have publishers and titles here. To close this, last thing I wanted to show is another product, this time on the server side. This is SharePoint 2010. Starting with SharePoint 2010, every SharePoint site, every list and every document library is exposed as a data service. So I can get at that data as a structured data, in addition to of course, being able to get it through the UI. So I have an employees list, for example, here, that you can imagine being related to the books and the publishers. So for every site, I can go to the URL. There is a magic URL that sort of is the entry point to the service. And I can see this format is identical to the one we saw before. Before we had titles and publishers. This time we have employees, calendar information, and so on. So if I say, for example, employees, again, an Atom field, nothing invented. This is just standard stuff. With all the SharePoint data, again, I can do gets and puts and stuff. And if I have an HTTP stack, I can interoperate here. If I grab this URL, just like before, I can come to Power Pivot, paste it in. I have all the list of lists, in this case, and document libraries. I can pick any one of them, click Finish, and now Power Pivot will import this into in my Power Pivot sort of data preparation space, and then from there, I can bring it directly into Excel. So here you go. I just in a few minutes brought data from a couple of places. Now I can mash it up together, build a nice spreadsheet, and maybe push it back into SharePoint and share it with everybody else.
That's great. Well, thanks, Pablo.
Thanks.
Great stuff.
Bye.
We're continuing also to evolve SQL Server to be able to process all types and shapes of data. We announced earlier this year we're introducing a new engine which we call Stream Insight. Stream Insight is a complex event processing engine. Stream Insight will enable you to process high-volume event streams and act on that information in real time. We've done some work with Microsoft Research to evolve the relational algebra such that you're going to be able to write rich queries using the operators and tools you're familiar with. Stream Insight will release in SQL Server 2008 R2. It will have a link programming surface, and the tooling experience will be integrated into Visual Studio. There are many applications of this type of technology. I thought what I'd do is take you through some examples as we've been working with customers and ISVs as we've been developing Stream Insight. The first is from McLaren. I think you probably recognize the McLaren brand name from the Formula One racing team. And this application, Atlas, actually was first authored to take the sensor data off the Formula One cars to monitor and diagnose performance issues. Now, they've taken Atlas, and the graphic here on the screen is actually of a healthcare example where they're monitoring an event stream coming off of patient monitoring data. This next example, Microsoft announced earlier this year that we were partnering with NBC to produce an interactive version of Sunday Night Football. And this interactive version is live as the broadcast is going on over the air. It's a tremendous experience built on Silverlight. You're able to sit basically in your browser and click among the various camera feeds. It's kind of like being in the control room during the live broadcast. It's an amazing way to watch football. Now, the Stream Insight application was basically a classic kind of clickstream processing application where we're using it basically to capture the clickstream so we have real-time insight into what users are watching and when. The third example is we're working with one of our partners, OSIsoft. OSIsoft is a leading solutions provider in many domains. Think of heavy industrial and oil and gas. Their solutions basically process a lot of events coming from the edge, from sensor data. They do some processing, bring it together, aggregate it so they can monitor and optimize the environment. And they've committed to work with us to adopt Stream Insight in future releases of this. You know, Stream Insight is bringing new capabilities to SQL Server, and there are many domains this is going to enable, from processing data from sensor feeds, financial transaction data processing, to systems management applications, and others. We think there's a lot of exciting applications of this technology, and it's going to bring a new level of real-time insight to the platform. So last is the promise of delivering pervasive insight. I think all of us in our day-to-day jobs find those points in time where we have a question that we must get answered in order to move forward, and we know that out there somewhere in our databases and our applications is the answer to it, and we're just some distance away from getting that answer. We think about pervasive insight, we think about shortening that loop to enable all users to get their questions answered out of the data that's in their environment, to gain business insight to move their business forward. We're moving forward to deliver